In this tutorial, we'll learn how to combine 3D.js scans with real-life footage using the 3D.js render add-on for Blender by KIRI Engine. Okay, before we get started, let's look at the footage that we're going to use as our background. As you can see, this isn't the nicest place in the world, so why have I picked this place? Well, if I open a still from this video as an image texture, we can see details, 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 areas of contrast, details, details. Every single surface in this picture has details or features. And just like photo scanning, if you wanted the motion track in this room, it would be fantastic. If you wanted the motion track in this room, it would be a nightmare. So I've specifically went to a location that I knew had details everywhere to motion track. Secondly, since I was using a DSLR, I've pushed the shutter speed high enough that there's almost no motion blur. If you're using a phone to record and you can go to 60 FPS rather than 30 or 25, I advise that, but it's best if you can to try and use an actual DSLR to film and make sure that your shutter speed is high enough to try and get rid of any motion blur. Now let's look at the model that we're going to put into our video footage. As you can see, this is actually a full scene scan, but for our video footage, I've cropped it down to this isolated model. I'm not going to cover editing 3D.js models extensively here because we already made a quick guide on that you can find on our YouTube channel in the quick guide playlist. I filmed my video in 4K, which could get a bit heavy for motion tracking. So let's convert this video using Blender into a smaller 1080p image sequence. We'll do that by first going to Blender, going to a new file and opening video editing. I can then drag my footage onto the timeline and then snap it to the start of the timeline with Shift S, and I can set the end of my timeline pressing page up and down to snap to the end and Control End to set the end of the timeline. Okay, we also want to match our frame rate, and if I go to this video properties, I can see that it's 25 frames a second, which is correct in Blender. I can see that my current render resolution is 1920 by 1080p. I can set my output folder and I'm going to save PNG image files. Now I can press Ctrl F12 and Blender is converting this video into an image sequence that I can see in the image sequence folder. Having this video converted to 1920 by 1080p and as an image sequence should make working a little faster once we're motion tracking. Okay, now we have our video as an image sequence and I have my 3D.js file. We have everything we need to get started. So let's jump into Blender. I'm going to start a new project, new, and I'm going to choose VFX. This will start the file in the motion tracking workspace. And I can see this area is where I load my video or image sequence. So I'll press open and I'll find my image sequence and open clip. Whenever working in the motion tracking workspace, we want to cache our clips to make playback and tracking more responsive. We can do that by going to Clip, Prefetch, and pressing it, and we can see that this purple bar at the bottom will show all of our cached information. Now if I play back, things are looking much smoother. The first thing to know is I am by no means a motion tracking expert, but there are plenty of really good tutorials on YouTube. I'll link some in the comments below. The first thing we want to do is to add some trackers to our footage. So we need to find some details of high contrast in our footage that we can use to track. We could do this manually, but I'm going to let Blender do the hard work by using the Detect Features button. If I press this, I can see a number of trackers have been added, and I could play with the features, but I'll leave it at default for now. Something very important to note is you can get wildly different results depending on your pattern size, search size, or motion model, as well as prepass and normalize. One quick hack, if we find this little list icon here, is Blender comes with a few presets built in. If I try the preset for blurry footage and detect features, and then track markers forward with this button, and then go back to my original frame and track backwards, I can see that none of my trackers get lost or look too erratic, because we're only currently trying to track location. I'm going to select all the trackers with A and delete them. Let's see what happens if I use the fast motion preset. Now we're set to location and rotation. Let's detect features, track these forward with the right arrow button, go back to our starting frame, track them backwards, and we can see that none of our trackers are too erratic or are getting too lost. I'm going to quickly delete these trackers just to show you an example again. If I went to the default tracking settings and I set this to perspective and detect features and again track, we again get tracked points, but this time we're trying to adjust for any deformations caused by perspective shifts. The correct motion model totally depends on your own footage. My advice, if you don't know which motion model to use, is to try out some of the presets and test different motion models if your tracking is failing. Now on this lower graph, if I zoom out a little bit, I can see some super spikes here and here. We can tell pretty much immediately from these spikes that these are going to be bad tracks. So I'm going to select this spike on the graph, hit X to delete, and do the same with this one. Now, over in the Solve tab, I want to specify 2 keyframes where there's the biggest shift that I can find in perspective. Let's say 55, and let's call it 200. You could let Blender find the keyframes for you, but I find this slows the process down a lot. I know the focal length of the camera I used, but just to be complete, I'll let Blender figure that out by ticking focal length, and I'm going to hit Solve Camera Motion. Up here, I have a solve error of 0.46. Anything under 1 is pretty good, so I'm quite happy with these results. If you're getting higher values, you can go to the Cleanup tab and hit Clean Tracks. Then start to drag up the reprojection error value. You'll immediately select all the trackers, keep dragging it up until you select only 1 or 2. So I've now got 1 tracker selected, so this one must have the highest error rate. So I could delete this and again solve my motion, and I can see that the value is even lower, 0.38. If you're getting really high values above 1, my suggestion is try to choose some different keyframes, or go back to your track and try changing the motion model or using one of the presets, as I said before. Now that our footage has been tracked, we can see that we've actually got a 3D viewport up here in the corner. In the Solve tab, I'm going to scroll down till I find Scene Setup and Orientation. I can select 3 trackers on the floor of my footage, and I'm going to press the button that says Floor. This has oriented our camera in the viewport. I can pick 1 tracker to be the origin of my viewport and set origin. And then in Scene Setup, I can set as background. And to test the tracking, I can set up tracking scene. This has added a ground and a cube to our scene, and some collections and view layers that we don't actually need, but we'll look at those later. I can go to my 3D viewport by hovering my cursor over this area and pressing Ctrl spacebar to maximize this area, then pressing spacebar again to play. It's kind of hard with the cube sitting below the center of the world here to tell what's going on, but since this is a standard Blender cube, I can press G, Z and 1 to move it onto the floor. I can then press Ctrl A and apply all transforms, so its origin is at the center of the world. Now if I press GX or GY, it's much more easy to move on the floor. I'm going to hide this ground plane for now. Let's go to top view, duplicate our cube a few times with Shift D, maybe scale some of them up, scale some of them down, and let's play back our footage again. And I can see that the track is good enough for what I'm doing right now. So I'm going to delete these cubes, and at the top header, press the plus icon, add a new layout, and if I look through the camera view, I can see there's my footage. At any point I can enable or disable this footage by selecting the camera, going to the camera properties menu and disabling background image, or changing the opacity of the background image. When we press Setup Tracking Scene to test our footage, that also created some unnecessary view layers and some unnecessary collections and a bunch of nodes in the compositor. I'm going to clean things up a bit by checking my view layers and deleting this background layer, and then taking everything out of these collections, deleting the collections. And I don't need this ground plane for now, so I'll remove it. In our compositor, I'll keep everything as it is for now, but I'll untick use nodes. Now we want to bring our 3D.js object into Blender. So I'll press the N key to bring up the N panel and find the 3D.js render add-on. Go to 3D.js, import, press import PLY as splats. OK, find my already cropped PLY file, and here's my 3D.js scan. I'll press RZ to rotate him on the Z axis, then G, Shift Z to move him on the axes except the X axis, so he sticks to the floor, put him in the position, and scale him as I like. But we can see by these kind of stripes that the object isn't appearing as we want. That's because we need these faces to be oriented and scaled to the camera view. Let's enable camera updates for this object and press use active camera. So now whenever the camera moves, the faces will update their rotation and scale accordingly with the camera position. Because this is a single object, not a full scene scan, I can even go to HQ/LQ and set its material to HQ mode for a better representation of the final product. Now if I go to material preview, I can see the scan on top of the footage. But one thing about this scan is actually bugging me, and that's the feet and these barriers around the feet here. These were actually part of the original scan, but what we can do with Blender and the 3D.js add-on is combine 3D.js objects with mesh objects. So if I go to edit mode and wireframe, I can select the parts of the scan that I don't like. Currently I'm selecting vertices. I want to remove full faces. So after selecting any vertices, I'll press Ctrl+ on my numpad to make sure I'm selecting a full face, and then delete. Okay, now that I've removed his feet, we need to give him some new mesh feet. I'll do that quickly by adding some cylinders. Beveling the cylinders a little so they aren't too sharp. Duplicating for the other foot. Giving them a new material that samples colors from the 3D.js model and moving them into their own collection. And I'll move them together back into position, and that should be fine for now. We'll adjust the feet color later if we need to. The objects move with the camera tracking, but one thing I can see immediately is my objects are casting no shadows, and that immediately breaks the illusion. To get shadows, we need some lights. So let's go in the shading tab to the world shader, and I'll add an HDRI texture. I want something that matches the overcast cloudy day of my footage, and Blender actually ships with a number of HDRIs. If I go to open, I can see that in the install files for Blender Foundation, I can find the data files folder, and in Studio Lights and World, we have the HDRIs usually used by Material Preview. I'm going to select this overcast urban HDRI. It would be better if I captured something on site or spent some more time getting a matching HDR, but it should be fine for now. If I pump up the strength of the HDRI, I can see that only my feet meshes are responding and no shadows are being cast. So first, let's select our 3D.js object, and in the add-on, go to Color and disable Shadeless. This object should now react to world lighting. And if I add a plane, I can see that my objects are now casting a shadow onto this plane. I'm going to do something that might help us a little later on, which is giving this plane a texture that somewhat matches our background. In shading, I'll give the plane a material and I'll call it Shadow Catcher. For our image texture, I'll use one of the frames from our image sequence. We're currently projecting the whole image. I only want to grab a portion of the floor, so I'll go to the UV editor and I'll adjust the UVs to just grab some of the floor here. So our plane is now receiving shadows, but it's covering up our background footage, which we don't want. If we were using cycles and we go to rendered mode, we could set this object in the object visibility. We could set it as a shadow catcher. And that way we could isolate the shadow information. However, 3D.js objects aren't optimized for using cycles. Cycles can be used, but we have to push the transparent bounces very high to get any acceptable results. I want to stick to using Eevee, but I want to use the shadow catcher from cycles. So I'll show you a quick hack so we can use both. Select the 3D.js object and make a duplicate of it with Shift D. I'll call this object duck to mesh and my original object duck 3D.js. I'm going to hide the 3D.js version for now, and our duck to mesh version will convert to a mesh using geometry nodes. I'm going to apply all modifiers for this object. I can do this quickly with Ctrl A, visual geometry to mesh. All the modifiers are gone, and this object will no longer respond to camera updates in the viewport. Let's give it a new geometry nodes modifier, and let's open a geometry nodes workspace. I'll add a mesh to volume node, and then I'll add a volume to mesh. And we can see that we've converted it into a mesh, a pretty ugly looking mesh. So let's try increasing the voxel amount and bring the density up a little, and play with these settings until you've got something that can cast a shadow. It doesn't need to be beautiful since we'll not actually be seeing this mesh at all. I can smooth it out a little by adding a smooth modifier and cranking up the repeats. And this should do the cast a shadow. So I'll again Ctrl A, visual geometry to mesh to apply all the modifiers. I'll unhide my duck 3D.js just so we can see what we've got right now. We have our original 3D.js object, and we now have a mesh version that's a little rough, but it's okay. And we have our mesh feet, as well as a plane, which we'll use as a shadow catching object. I'm going to rename my scene to Eevee, and then create a new scene with a full copy, and I'll name this cycles. In this new scene, I want my feet, I want my plane, I want my camera. I don't need the original 3D.js object, so I'll delete it. And I just realized there's a light hanging around from our motion tracking setup. I'm going to delete that light in both of our scenes. And in our cycles scene, I'm going to add all of our duck meshes into a collection. Call it duck cast shadow. Then enable some more toggles in the outliner. Enable the indirect only toggle, and I'll set the duck cast shadow collection to indirect only, and this scene will use cycles. We can see now that all the duck meshes have disappeared. They're still there in the viewport, but they're only contributing to the shadow we're casting on our plane. And because we're now using cycles, the shadow catcher option is allowing us to isolate only the shadow information. So we have one scene named Eevee, which we'll use to render our 3D.js objects, and we have one scene named cycles, which we'll use for shadows. Back in the Eevee scene, I'm going to delete the mesh duck since we don't need him, and I'm going to delete the ground plane since we don't need it. We have our Eevee scene and our cycles shadows. You can play with the cycles samples. I'm going to make them super low because I only care about render time, but you should do some tests to see what causes flickering in your animation or not. In the cycles scene, I'm going to make sure that compositing is disabled and I don't need any of these nodes. And in my Eevee scene, we'll do all of our compositing, so I'll enable use nodes. Then in the compositor, we have our video clip, and I can preview it with Control Shift and clicking this chain. And we have a render layer node that is set to our Eevee scene, and we have a render layer node that is also set to our Eevee scene. Let's disconnect both of these for now, and let's set one of them to use our cycles scene. Then let's press F12 to render. After rendering, we can now preview these two nodes with Control Shift, clicking the node, and we can see here are our shadows from the cycles scene. And here's our 3D.js and mesh feet from the Eevee scene. We want to put the shadows from cycles on top of our video footage. We already have this alpha over node from the motion tracking step, and the bottom socket is the on top image. So I'm going to connect my cycles to this alpha over and preview it, and I can see that our footage now has the shadows. We then want to put our Eevee render on top of this, and we already have this alpha over from tracking. So let's plug in our Eevee and preview this, and there we go. To get a better view of what's happening, let's turn this lower timeline window into an image editor, and let's select viewer node. And now whatever our viewer node is connected to with Control Shift clicking, we can see in this window, and it's much easier to navigate and zoom in and out. We can now go a step further by trying to match some of the colors of our render to our background image. First, a little disclaimer, I am by no means a compositing wizard, so you'll probably find something better if you search YouTube for a compositing tutorial, but I'll try my best. First thing we're going to do is add 3 RGB curves. 1, 2, and 3. I'll make them a bit wider so it's a bit easier to read them and to edit the values. Then selecting this node, I'll go to the node properties and give this a color, red, green, blue, and I'll plug in my Eevee render and connect these to the alpha output and preview the end result. I'll set my red node to only affect the red channel here, green to green, and blue to blue here. We can then control each of the individual color channels using each of these nodes. So that we're not distracted by looking at colors, I'm going to do it channel by channel. Let's go to the red node first, and in my viewer window, click this drop down and select red, and we'll try adjusting the black point of this image to integrate it better. I can do that with this little corner spot here. If I select it, I can adjust the values here, and I can do incremental values by holding Shift while I scroll each value. I could do this by eye and change these values little by little. If you're changing values and you see that the whole image is changing, check in your alpha over nodes for convert pre-multiplied. Now we can see that we're only editing the render itself. I can try eyeballing this and changing the values till the render looks a little more integrated, or from the end panel in the image editor, I can find scopes, and I like to use the sample line. Let's make this a little bigger and set this to also be our reds. So we have red, red, and red. Now if I click sample line, I can draw a line through a dark part in my background and a dark part of my 3D.js object. If you have no idea what you're looking at here, try changing some of the values and just see what happens. If I change the black point, I can see that these two little wells here changed. So that must mean that these two spots here are the two spots where we cross the line on the dark legs. And this spot here, this dip, this well, must be where we're crossing the line on our background here. So we want to make sure that the lowest point on our background matches the lowest point on our render, which right now in the red channel, it actually looks pretty good. If I redraw the line from some light white parts of our background, crossing through the white areas of our render, we can check the highest points of the background and the highest points of the render. Everything's actually looking pretty good in the red channel, so we can now move to green by pressing G here, switching our view to green, and now we'll start messing with this green curves node. I'll redraw my line to go through the dark part of the image and the dark part of my render, and I can immediately see that these two spots here, which I believe are the legs, are a bit lower than this background spot here, which I think is this tube. If I manipulate the black point until these two spots are at a similar level to this spot here, I can see that the render is more integrated into the overall picture. I can actually view the effects by muting this node by selecting it and pressing M. And the difference is very subtle, but very important. Now let's move to our blue curves by setting this to blue, setting our viewer to blue, and working with the blue black point. And sometimes viewing the image as a thumbnail by zooming out can help you check if everything is fitting or standing out too much. To To return to the full color view, go to Color and Alpha, and you can select all of your curve nodes and press M to check before and after. Even if the difference is very subtle, it all helps in the end. Now we want to try and match some of our saturation. In the image editor viewer node window, if I hold Control and right mouse button click, I can see that at the bottom of the screen a number of values will pop up. Wherever I hover my mouse, I'll be reading values from that area. If I find the most saturated point in the background, which could be this red or this blue here, I'll see that we get a saturation value of around 0.5, 0.6, 0.5, almost 0.6. And if we check the hair of the bird, the saturation is around 0.8, 0.9. So let's add a hue, saturation and value node. And let's try bringing down the saturation and checking the levels again. Now saturation is about 0.6. Let's bring it down some more. 0.5, 0.6, 0.5. I think that should be okay. And let's again use M to mute this node to view the changes. Now for some finishing touches, renders are always way too clean, so let's mess it up a bit. We can do that by adding a filter node and setting it to box sharpen, and it's way too strong. Let's try 0.1, maybe 0.2, and then let's blur maybe a couple of pixels, maybe set this sharpen to 0.1, and that'll help a little in making it less perfect. We can also add some noise by adding a texture node and creating a new texture, and we can find that texture over here in the properties. If we hit texture, let's give it a name, let's call it grain, and the type will be distorted noise. Let's preview with Control-Shift-Click, and it's way too big, so let's set our size to something tiny. I'll type 0. And for a nicer noise, play with the distorted noise type. And so that it matches our video footage better, let's set the X scale to be our aspect ratio, 1920 divided by 1080. And we want this to change each frame, so let's go to the X offset, hash frame, and let's multiply that by 7. Now every frame we get some different noise. We can use a mix node and set this to overlay and plug our new grain texture into the bottom. And we can bring this down so it's very subtle, but without it, our render is way too clean. If you wanted to do an even better job, you could play with adjusting the shadows, the shadow color, getting a better matching HDR, and maybe I should have tweaked the gamma or contrast a little more, but I'd say I'm happy with this for now. If you want to learn how to render 3D.js scans alone, or edit and paint 3D.js scans, we have special quick guides just for those subjects.